Oh, hello there. Just sitting here, watering the plants. Oh, yes. I'm seeing if I can sprout them up again. They look a little dead to me. What do you think? You think it's gonna work? No, neither do I. Okay. So, maybe we should just make it okay so. Good day, good morning, good afternoon, whenever you're watching this. It doesn't matter when you're watching it because it's on your time. Yesterday, we talked about categorical data, which is talking about things, right? Today we're going to be doing numerical data. Now, numerical data deals with measuring of certain items and then comparing them and seeing how they fit together. So we're going to be doing a little experiment, just like yesterday when we counted cars. So my yard looks a little bit better. Still not that great. Work in progress. I can't seem to get the grass to grow, so anybody that knows how to grow grass, parents that want to help me out with some tips and yard upkeep in general, I'd greatly appreciate it. Let me show you what the yard looks like. So I like that grass over there. It's not bad, but this right here, that's where my dogs go, and I can't stop them. We actually had that hole filled in. Okay. What we got here today is I got some mugs. And we're going to go through each and every single mug. Let's see what we got here. We have Charlotte Christmas Village. All right. So we've got Charlotte Christmas Village. Why do we have two of those mugs? We have a little interesting mug. Oh, it's mine. Look at it. It says Doug on it. Myrtle Beach. Awesome. And then we got this one. Oh, look at it. It's lovely. Douglas and Danielle. 3 in a row. Always, love always wins. Oh, that's beautiful. That's beautiful. This is the best one. PGA Championship, Quail Hollow. Got to go to 2 practice rounds. Maybe 1 round? Maybe Friday? I don't know. But it was great. I love that. This is just a really big mug. And what's this one? Hey, look, there's a golfer on it. That should be mine. But it's not. It's Danielle's. Yeah, Myrtle Beach. All right. So what we are doing today with these items is we are going to be... What we're doing today with these items is we are going to measure how much water they catch. So this is, for example, my lawn. Okay, I do not have a sprinkler system, but I have the hose that you saw me watering my blocks of wood with. What I'm going to do is I'm going to set up the mugs around the yard, and I'm going to be like the sprinkler system, and I'm going to try to do as evenly as possible all the way across. And we're going to see how much is actually filled in each mug. I let Ms. Pearson, everybody gonna give a shout out to Ms. Pearson. Ms. Pearson let me borrow a graduated cylinder from her room before we left, and we're going to use that to measure how much water was filled inside the mugs. Now I have different size mugs, so we would assume, we can make an assumption to begin with that, okay, hey, the smaller mugs are going to have more water in them because they're smaller, or the larger mugs are going to have more water in them because they can hold more. But a sprinkler system is supposed to make sure that everything stays even, so that way all the grass in your yard gets covered with the same amount of water. This could help you when you're older, because if you actually do install a sprinkler system, or you have a sprinkler system, or you're doing it like I do with the hose, you know what areas of your lawn aren't getting hit. Be a cool little idea. So let me put the stuff around the lawn and let's get started. that way they're all in the same radius. They're all kind of the same distance away. Not perfect though, the way I set them up, but that's okay. So I'm gonna start not putting the water on any of them, making sure it goes, and I'm just gonna try to go just around. Okay? And how much water actually gets in them. I don't know if it's gonna reach all of them. That might not be the right setting. Full? Full might be better, right? Do full. I can't let Moose out. I don't know if you can hear him clawing next door. Moose loves water. He absolutely loves the hose. It's his favorite thing ever. And he freaks out. He freaks out when he sees the hose. So that's one. What I'm trying to do is trying to get this apart over the top of each of them. Well, try to keep it the same thing. This is not a perfect test. Because obviously an actual sprinkler would have this everywhere. Or, you know what I'm saying. Just enjoy me spinning and getting dizzy. All I can tell you. Enjoy me spinning and getting dizzy. What are you all doing right now? Besides listening to me and enjoying life so much. Everybody doing alright? Everybody cool with their time off so far? Everybody did their MasteryConnect yesterday, right? Better than MasteryConnect yesterday. Technically, I know I'm filming this yesterday. Technically, I already know it. I'm asking anyway. You're lying. What you doing? I'm gonna remind you of rain and all. Raindrops are falling on my head. Do this for a little bit more. If you want to skip, like do it extra, like a 10 seconds faster on the video, that's fine. That's not going to bother me at all. I'm just showing you, or I'm just doing it so that way the results end up at least a little bit somewhat valid. And what I mean by valid is that I'm not just sitting here looking at the one that has my name on it, my favorite one, and putting all the water in that. That wouldn't be valid. That wouldn't be fair. I need a true test of what this is actually doing to make sure that we have something we can measure. Got it. You're on my roof, by the way. Let me come get you. Oh. Yeah, I'll see you inside. All right, so count. We are going to measure this data. As I was obviously there's time that's going by in between these little snippets of clips, and I'm sitting there thinking, so these are the thoughts that go through my mind as a teacher, and how I want you to think about things as well. So I'm thinking of the best way to teach these things from home, and obviously trying new ways to do it. And I want you to notice that I struggle just as much as you do, but when I'm in class with you, I'm preparing for it. I'm completely prepared for it. For those of you that have led groups in class, you know it's much easier when you understand it completely. Now, it's not that I don't understand this, but teaching it in a way that's not just, oh, here we go, here's some data. So I was thinking about how putting this into a line plot was going to show the difference between the numerical and the categorical in between these little breaks. And I was sitting there thinking, hold on a second, if we have 7 cups and I'm just comparing the data there, couldn't that also be just categorical? Because, okay, the green cup has this. So what I'm going to do off camera is I'm going to gather a bunch more. I'm going to do this a few more times so that way you don't have to watch me sit around in circles with water for a while. And we're going to get a whole bunch of data points. And we're going to put them into a chart, and then we're going to graph them from there. All right? But first, let's do these 7. Let's do these 7. So, sorry. So there's our data from yesterday. Let's do this. So we'll call it sprinkler system. Now, the points of data that we're going to have, we are going to take this graduated cylinder that, again, Ms. Pearson let me borrow, and we're going to measure the water that is in each of these mugs, and then I'm going to go ahead and I'm going to measure the rest of them after we do these 7, and we're going to come up with a whole list of data, and then we're going to put them in a line plot. So, if you do not remember how a graduated cylinder works, these are measured in milliliters. I don't know if you can see that. There we go. Measured in milliliters. So in this entire thing, it says it's got 100 milliliters in it. And if you look, it's counting by tens. So way down here, there's going to be the 0 to the 10. And then inside of each of these are each milliliters. So when we do it, we have to fill it up. So let's do the green mug first. And it's probably not going to be as much as you think it's going to be. Drips in, probably as much as we're gonna get. Okay, so now actually I had to keep it flat. Now if you've ever used a graduated cylinder before, we need to look at the meniscus. And what the meniscus is, you see that little almost like rounded bubble there? We have to do it by the bottom of that. We don't have to be perfect with this. We're doing math and we're just kind of looking for stuff, but that's just something important to know. So we have to count how many lines we have here, and it's not at 10, so that's going to make it very, very tough. Well, now let's use some math reasoning then. If this is 10 and each of these is a milliliter, where do you think this lands? Do you think it's exactly half? Neither do I. I think it's probably 6, right? So let's label this one as, so we have 6 milliliters for the first. And then I'm going to put it back inside of the green. Let's do this red one next. Whoop, whoop, whoop. Came out a little faster than I thought there. Alright, come down here. So if this is 10, and we can think of it, half of it is 5, what do you think this one is? Kind of compare it to this portion here. Do you think it's just 1? I think it's 2. I agree, I would say 2. So we're going to do, for the next one, we got 2 milliliters. Small m, big L. I guess it doesn't have to be, that's just how I've always done it. Put that back in. Let's go with green Christmas mug. Oh, that didn't have anything, did it? Where are we at there? Probably 1, right? I would agree. Yeah. 1 milliliter. Put that back in. Let's go. The love mug. The love mug. It's so beautiful. What we got there? So again, we're trying to compare it. So I know we don't have lines down here, but we got 1, 2, 3. It's like that. No, it's probably, what do you think, 4? go the Quail Hollow mug, PGA Championship. Interesting. Not a whole lot in there. What do you think? Maybe 2? I think we got 2 left, right? No, yes, 2 left. We got the Douglas and Danielle mugs. Mr. Doolen, Mrs. Doolen. Ooh. That had quite a bit in it. There's that 10 mark that we can see. Oh, there it is right there. So there's 10. What do you think we're at? Almost 9, right? Let's go 9. And then let's see what Danielle's got. Let's see what Mrs. Doolen has. Nothing. Nothing. We have 0. No, we still have to mark it down because we're collecting data. So let me go and do this a few more times. I'm going to measure it so that way we have a big assortment of data. Okay? All right, I'll be right back. Okay, we have our data. If you need to, pause this video so that way you can write down this data in your own notebook. So I did it 2 more times with these 7 mugs that I have, which means we have 21 we should have in total. 4, 8, 12, 16, 20, 21. Yep, very good. Now from here, let's create our line plot. Again, I always like to do my y-axis because I just like getting in the habit of making sure I know what that is. So in this case, because I have all these different numbers, I'm looking for the less number and the greatest number, and I'm going to number them across. What is the least number that we have? 0, right? We have 0. And what is the greatest number that we have? 13. So way down here, I'm going to put 15. I like it being kind of even that way. So in between here, I'm going to make sure that I have everything kind of labeled. So I got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Kind of screwed up there. That's okay though. And then just to make it a little bit easier, I'm going to separate each of these so that way I know where to put my X's. Now, I know I said I was going to do fractions, but I didn't realize that it was going to have this little bit of not as much water in here. But like I said, don't worry about it. This is more review so that way we understand how to do this, how to read them. So in this case, now we're going to go through here and we're going to put X's over every single time we have it. And the best thing to do is to mark off when you've done it. So I'm going to start from the top. I got 6. I'm going to put my X, only half of the line, and mark off my 6. 2. 1. 4. 2. 9. 0. 3. 2. 7. 1. 11. 3. 4. 5. 2. 1. 9. 6. 13. 3. Very good. So, knowing that I did this 3 times with the 7 mugs, let me say that again, 3 times with the 7 mugs, how many X's, or how many trials, or how many items did I actually collect? 21. Now that should be represented by those X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I think I missed the 5, 21. So because I screwed up there, what you need to get in the habit of is just doing it again, double checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Very good. So now here's my question. Which mug, or what was, sorry, my fault. I was kind of going categorical question. I need a numerical question. What was the greatest amount of water collected? Let me ask it again. What is the greatest amount of water collected? Your answer should be 13. That was the most water collected, right? Now, you saw 9 as the most when we were actually filling it. I had one that was 13 afterwards. That 9, think back to that 9. Didn't that 9 have the most water inside of this cylinder? That's the greatest amount of water that was collected. Some people might have said 2. Remember, we're reading this a certain way. The question was, which was the greatest amount of water collected? This would be the greatest amount of water collected. What was the most common amount of water collected? That answer would be the 2 milliliters, because it was collected 4 times out of the 21. So now those crazy questions. What is the difference between the most water collected and the least water collected? What was the most water collected? We know it to be 13, right? So I'm going to write 13 right here. And what was the least water collected? Think about what a test maker is actually trying to ask on this one. What did we collect any water if we have 0 here? No, we didn't collect any water, right? It was in the trial, but we didn't collect the water. What was the least amount of water collected? 1. So we're going to have to do on this one -1, because we're looking for what's the difference between the greatest amount and the least amount. So 13 minus 1 would be 12 milliliters difference. So now, the big figure, the big question, the one that takes the most time. If I were to take all of these amounts of water and put them into this graduated cylinder, how much water would there be? Well, we need to do some different type of math, right? We could do, how many 1s are there? There's 3 of them, so we could do 1 plus 1 plus 1. How many 2s are there? 1, 2, 3, 4. So plus 2 plus 2 plus 2 plus 2. How many 3s? 1, 2, 3. Plus 3 plus 3 plus 3. You guys seeing what? You already know what I'm going to say, right? Plus 4 plus 4. Plus 5. Plus 6 plus 6. Plus 7. Plus 9 plus 9. Plus 11. Plus 13. Now the reason why I had to write all this out, and I know you guys aren't even writing it out anymore because you already know I don't like that. The reason why I'm writing it out is so you realize that it's not 1 plus 3 plus 4 plus 3. Each one of these X's again represents the amount of times that amount of liquid was collected. 2 was collected 1, 2, 3, 4 times. So if I were to take all of those 2's and put them together, it'd be how many? It'd be 8, exactly. So what would you do different, or what do you think I would say to do different with these things instead of just adding them up like this? Because I'm already going to get confused here. I already know me. If I'm looking at numbers like this, I'm already going to get confused, and I'm probably going to make a silly mistake that I don't need to. What would I tell you to do you think? Well, what I would do is I would look at each one and I would write it above the number, the X's. So 1, 2, 3. This would be 3 milliliters because 1 times 3. 2, 4, 6, 8. I'd write an 8 up here because it's 2 times 4. 3, 6, 9. I'd write a 9 up here because it's 3 times 3. What's above this one? 8. Why? Because it's 4 times 2. What's above this? 5. Why? Because it's 5 times 1. What's above this? 12. Because it's 6 times 2. Above this? 7. Because it's 7 times 1. What about here? 18. Because it's 9 times 2. Twice I found 9 milliliters. This would be 11 because it's 11 times 1. And this would be 13 because it's 13 times 1. Now we have a lot easier thing. And look what I did here. I used parentheses to separate all these so you could see it as 1 times 3 plus, a plus sign in between each of those, telling me that that's what I have to add. And now it's a lot easier. 3 plus 8 is 11. 11 plus 9 is 20. Actually, I'm going to stop right there. I want you to pause the video and tell me how many milliliters this is in total. And then press play and see if we're right. Okay, so what you should have done was 3 and 8 is 11, plus 9 is 20, plus 8 is 28, plus 5 is 33, plus 12 is 45, plus 7 is 52, plus 18 is 70, plus 11 is 81, plus 13 should be 94 milliliters, which would actually fit inside of this graduated cylinder. All 21 of those mugs filled over those 3 times would be all the way up. If it's 94, would fill all the way up to here. Now I've already dumped them out and stuff like that, but I kind of want to show you what that would look like. So let's go fill it up. So my battery died, but it would be like this. I think I have it at 92 a little bit. There's 90 and 92, but that much of the water would be filled over those 3 times. All right, now for some fun stuff. Let's show Muth and Henry. Most, do you want to chase the water? Oh yeah, he does. Do you want to chase the water? Back up. Back up. Ready? Go get it. Oh yeah. Oh! Good jump. Ready? Here you go. Come here. Ah! What are you doing? Bye-bye.